If you look at human history, you see one thing above all else: we are explorers. From our first steps out of Africa to the day we left footprints on the moon, we've always been obsessed with what's over the next horizon. Today, that horizon is Mars. It's our next giant leap, a symbol of our wildest ambitions. We dream of Martian colonies, of red dust turning into green fields, of humanity becoming a multiplanetary species. But what if the ticket to that dream is one way? What if reaching Mars seals the fate of the first people who go? The first human to step on that red world will be a hero for all time. But that person and their crew might be saying a permanent goodbye to Earth. The dream of Mars forces us to ask a big question. What does it mean to be human? Is it tied to this planet or to our spirit of discovery? The first Mars astronauts may represent the dawn of a new, separate branch of humanity, Homo Martis. Forever bound to their new world, their bodies will be living monuments to the price of exploration. They would be the ultimate pioneers, trading one world for another, not just for themselves, but for all the generations of Martians that might come after. It's a staggering thought, but it may be the reality we have to face. The first humans to walk on Mars might not just be visitors. They might be settlers, arriving at a new world, knowing they can never go back. This raises a personal question. If you were offered a spot on the first crewed mission to Mars, but you knew it was a one-way trip, would you go? Let us know your thoughts in the comments below. And if you want to keep exploring the biggest questions about our future in space, make sure to subscribe and hit that notification bell. Thanks for watching. Now, this isn't about a dramatic explosion on the launch pad or a catastrophic failure millions of miles from home. This is about a hidden danger, a biological trap that springs the moment an astronaut leaves our planet. Their bodies will begin to change in ways so profound, so extreme, that coming back to the world that birthed them could be impossible. The very act of surviving the journey and living on Mars might be what makes a return trip unsurvivable. A crewed mission to Mars is the ultimate adventure, an undertaking that makes the Apollo program look like a weekend trip. While companies like SpaceX are aiming for uncrewed Starship missions by 2026 to test landing capabilities, with crewed flights potentially following in the years after, the plan is a marathon. The journey alone is a grueling 7 to 9 month flight through deep space. Then you'd spend at least a year on the surface, doing science and setting up camp, before another long haul back home. All told, you're looking at a 3-year commitment. 3 years is an immense amount of time. On Earth, it's long enough to earn a degree or watch a child learn to talk. In space, it's a sentence. A sentence served in an environment the human body was never, ever meant to handle. For those 3 years, these pioneers will be hit by 2 hostile forces: the relentless storm of deep space radiation and the sneaky, body-twisting effects of low gravity. This journey will change them, not just in their minds, but right down to their very cells. It is a one-way process of adaptation, a journey from being an Earthling to becoming something new. A Martian body, one so uniquely tuned to its new home that it may no longer be compatible with its old one. Part 1. Gravity's Betrayal, Your Skeleton. The most famous effect of long-term spaceflight is what it does to your bones. Here on Earth, your body is in a constant fight with gravity. Every step you take, every time you stand up, it puts stress on your skeleton. Your body responds by constantly remodeling your bones, making them strong enough to handle the load. In the weightlessness of space, that signal disappears. The body gets a new message. This skeleton is over-engineered. It's too heavy, too dense. So your body, always looking for efficiencies, starts dismantling it. This is called spaceflight osteopenia. NASA has found that astronauts on the International Space Station can lose bone density at a shocking rate, about 1% to 1.5% per month in critical bones. For comparison, an elderly person with osteoporosis loses that much per year. In space, astronauts can experience a decade of age-related bone loss in less than a year. Sure, they have intense 2-hour daily exercise routines to fight this, but it only slows the process down. It doesn't stop it. Worse still, it's not just about density. Research shows that even after returning to Earth and regaining some bone mass, the internal structure of the bone is permanently changed. It's weaker, more fragile. Now, picture the Mars mission. After 9 months of this in zero-G, astronauts land on Mars, which has only 38% of Earth's gravity. That's better than nothing, but it's probably not enough to stop the decay that happened on the way there. Their skeletons will adapt to this new, lighter load. But here's the terrifying question. What happens if they try to come home? After years of their bones being taken apart, and then rebuilt for a 0.38 G world, a sudden return to Earth's full 1 G would be a brutal shock. There now, Martian skeleton would be dangerously fragile. Just walking could lead to fractures. Their bodies, having shed the armor needed for Earth, would be crushed by it. Part 2. Gravity's betrayal. Your muscles. What happens to bone also happens to muscle. It's use it or lose it. The muscles in your back and legs that work all day just to keep you standing. They go on vacation in space. Without that constant load, muscle fibers, especially the ones for endurance, just waste away. Astronauts can lose up to 20% of their muscle mass in just a few months on a long mission. This isn't just about feeling weak. The heart is a muscle too. With less effort needed to pump blood, it can literally shrink. Again, exercise is the main weapon. Astronauts spend hours a day on special equipment to simulate weight-bearing exercise. It helps, but it's not a perfect fix. Muscle weakness can linger long after returning to Earth. For a Mars crew, the journey there would leave their muscles deeply deconditioned. Landing on Mars, even with its lower gravity, would feel incredibly difficult. But over a year, their bodies would adapt to that new, lighter standard. The return journey is the real danger zone. A body adapted first to 0G, then to 0.38G, suddenly hit with 1G. The weakened heart would struggle to pump blood against gravity, leading to something called orthostatic intolerance, where you can't even stand up without fainting. The risk of falls and injuries would be huge. While ISS astronauts recover with physical therapy, the sheer length of a Mars mission pushes this to a level we've never seen. The triumphant return would look more like a hazardous medical evacuation. As if the body wasn't falling apart enough from the inside, it's also under constant attack from the outside. Here on Earth, we live inside a giant magnetic force field that shields us from deadly space radiation. Leave low Earth orbit, and that shield is gone. You're sailing in an ocean of radiation. The main villains are galactic cosmic rays, or GCRs. These are high-energy particles from distant exploded stars, zipping through space at nearly the speed of light. They're like microscopic cannonballs that tear through the ship and the astronauts, shattering DNA and damaging cells. A round-trip mission to Mars could expose an astronaut to a massive dose of radiation. While estimates vary, data from probes suggest a dose of around 662 millisieverts MSV just for the journey, not including time on the surface. A 3-year mission has the potential to expose astronauts to over 1,000 MSV in total. For perspective, NASA's career limit for its astronaut 1,000 MSV, and your average radiation dose on Earth is just a few millisieverts per year. This exposure dramatically increases the lifetime risk of cancer. But it's not just about cancer later. The damage is immediate. A groundbreaking 2024 study in Nature Communications showed that cosmic radiation could cause permanent kidney damage. In mice exposed to simulated radiation for a 2.5-year Mars mission, their kidneys suffered irreparable damage and loss of function. The lead researchers warned that an astronaut might get to Mars, but need dialysis on the way back, a death sentence millions of miles from a hospital. Radiation also attacks the heart, hardens arteries, weakens the immune system, and even targets the brain, potentially impairing an astronaut's ability to think clearly during a critical moment. You can't exercise away radiation. Shielding helps, but it's not enough. The first Mars crew will be soaking in it for years, and the damage it causes is a huge reason why their bodies might simply be too broken to come home. On top of everything else, the journey will literally change how astronauts see the world. One of the weirdest medical problems from long missions is spaceflight-associated neuroocular syndrome, or SANS. NASA has reported that approximately 70% of ISS astronauts experience some swelling in the back of their eyes. On Earth, gravity pulls fluids down. In space, they shift upwards, increasing the pressure inside your skull. This pressure pushes on the back of your eyeballs, physically changing their shape and swelling the optic nerve. This can make astronauts more farsighted. For many, this fixes itself back on Earth. But for some, the effects are long-lasting. And for a Mars-length mission, we just don't know if the changes could become permanent. NASA considers SANS a top risk because an astronaut with compromised vision is a danger to the whole mission. The physical toll is only half of it. The psychological stress is immense. Imagine being locked in a space the size of an RV with a few other people for 3 years. On the ISS, astronauts can look out the window and see home. On the way to Mars, Earth becomes just another star. Communication will have a delay of up to 20 minutes each way. There's no real-time chat with mission control or family. Homely. After score, family. They will be utterly alone. This profound isolation can lead to depression, anxiety, and conflict. Simulation studies like Mars 500, where a crew was locked in a mock spacecraft for 520 days, prove these risks are very real. The environment is monotonous, same walls, same sounds, same smells. And all of it happens under the constant crushing pressure that any small mistake or failure could be the end. This mental stress creates a dangerous feedback loop with the physical decay, pushing both mind and body to their absolute limits. So let's put it all together. The crumbling bones, the wasting muscles, the radiation-scarred kidneys, the pressurized eyes, and the isolated minds. The argument for a one-way trip isn't about a single knockout punch. It's about the overwhelming, cumulative toll of all of it. A body that has spent 3 years becoming Martian is no longer an Earth body. Its bones are fragile, its heart is weaker, its DNA is damaged, and its immune system is compromised. Now, it's true that companies like SpaceX are designing missions with a return trip in mind. The goal is to bring everyone home. But the question is, could the body handle it? The sudden shock of 1G gravity could put an unsurvivable strain on the cardiovascular system. The skeleton would be at high risk of fractures from just moving around. Rehabilitation would be a monumental task, far beyond anything we've seen with returning ISS astronauts, with no promise of a full recovery. For the very first pioneers, the risk of bringing them back might simply be too high. The most humane option might be to accept that Mars is their new and final home.